Have you ever stopped to think about how your computer or even the phone right there in your hand actually, well, thinks? Deep down, inside every single processor, there's a core design philosophy, a kind of rule book for how it gets work done. And for decades, two very different philosophies have been in this silent war for control. This battle helps explain why the chip in your laptop is so different from the one in your smartphone. So let's dive in and see what's really going on inside the tech we use every day.
So it all really starts with a simple question. When you click something or type or swipe on your screen, what are you actually asking the computer to do? Well, you're basically giving it a to-do list. And every single item on that list is an instruction, a very specific command like, hey, add these numbers, or move this piece of data, or go load that image.
Now, the complete list of all the words a processor understands is called its instruction set. You can think of it as the processor's entire language, its whole vocabulary. And you might think a huge vocabulary would be more powerful, right? But what if a simpler, more efficient one was actually faster? This is the exact idea that splits our two philosophies right down the middle.
All right, first up we have the old guard, the original heavyweight champ. Its philosophy is basically more is more. I want you to imagine a giant Swiss Army knife, one that has a specialized, custom tool for absolutely every single task you could ever dream of. This is the world of the complex instruction set, or CISC for short.
The whole idea behind a complex instruction set computer, CISC, was to make life way easier for the human programmer. The goal was to give the processor this massive, powerful set of commands so that just a single line of code could kick off a really complex multi-step operation, something like multiply these two numbers and then store the result over here, all in one single command.
And when we say complex, we are not kidding. A typical CISC processor has a vocabulary of somewhere between 100 and 250 different instructions. It is absolutely armed to the teeth with commands, ready for basically anything a program could possibly throw at it.
But here's the crucial part. CISC instructions are very often memory-based. This means the processor constantly has to reach out to the computer's main RAM, its short-term memory, which, by the way, is way slower than the processor itself. And because all these instructions come in different shapes and sizes, supporting them requires incredibly complicated and power-hungry circuitry inside the CPU.
Now, to be fair, this approach had some real advantages, especially back in the early days of computing. It made writing software a lot simpler because one command in your code could match one powerful instruction on the chip. It also meant that programs took up way less of that precious, expensive memory space. But all that complexity, it came at a pretty steep cost. Researchers started noticing that most programs only ever used a tiny fraction of those 250 specialized tools. And even worse, for the CPU to actually run one of its complex commands, it first had to translate it into a bunch of even smaller, internal steps called microcode. Think of a manager having to write out a super long checklist for an employee. That translation step, it became a major bottleneck.
So this inefficiency really paved the way for a revolution. A challenger with a completely opposite philosophy. Less is more. So forget that giant Swiss Army knife. This new idea is like having a small, perfect toolkit with just a few single-purpose tools that do their job incredibly well and incredibly fast. And this is where we meet the Reduced Instruction Set Computer, or RISC. The philosophy here is just brilliantly simple. Why make the hardware so complex just to support instructions that are barely ever used? Instead, let's simplify the hardware down to only include the most essential, most frequently used instructions.
And the difference is, well, it's just stark. Compared to CISC's 100 to 250 instructions, a RISC processor gets by with this super lean vocabulary of under 100. It focuses on doing the basics, and it does them with just blazing speed.
You know, the secret to RISC speed is all about keeping things local and uniform. Instead of constantly reaching out to that slow main memory, all the operations happen in these tiny, super fast storage areas right on the chip called registers. Think of it like a chef having all their ingredients right there on the counter instead of running to the pantry every time. Plus, every single instruction is the exact same length, like perfectly uniform bricks, which makes them super simple for the processor to handle. And all of that allows for much simpler and much faster hardware.
All right, so we have our two contenders, the complex, do-it-all approach of CISC versus the simple, lightning-fast approach of RISC. So let's put them head-to-head and see what happens. This slide really shows you the fundamental difference in how they think. The CISC brain sends out these complex, winding instructions that have to go all the way out to memory and back. The RISC chip, on the other hand, keeps everything simple and crazy fast by just working with its local registers.
CISC is all about packing power into a single command. RISC is about executing tons of simple commands with raw, unadulterated speed.
Okay, so how does this actually translate to performance? Let's take a look. On the left, with CISC, you see that execution requires that microcode translation step, and that takes multiple clock cycles. But then, look over at RISC on the right. It uses direct decode and takes just a single clock cycle. This right here is the big payoff for keeping the hardware simple. Less complexity means fewer steps, which just means more speed. Simple as that.
So what's the big takeaway from all of this? I mean, why is simpler actually faster? And why does any of this matter for how fast your phone or your laptop feels? Well, it all comes down to the number of hoops an instruction has to jump through. So on the left, you can see that two-step CISC process. A single complex instruction has to get translated into many lines of microcode first. Only then can the CPU actually execute all those little steps. But on the right, you see the RISC advantage. It's just a one-step process. A simple instruction is decoded and executed directly by the hardware. No translation, no bottleneck. Boom. Done.
Yeah, this quote from our source material really just says it all. The ability to execute one instruction per clock cycle, that is the fundamental advantage that gives RISC its incredible edge in speed and efficiency. And it's exactly why it powers the vast majority of our modern mobile devices today. So, this whole battle that's happening inside our computers, it teaches us a really powerful lesson, doesn't it? Sometimes the most elegant solution isn't about adding more features, but about stripping things down to their most essential, most efficient form. RISC proved that less really can be more. It kind of makes you wonder, in a world that's only getting more and more complex, where else might radical simplification be the ultimate upgrade?